Another concept you're going to have to be familiar with is a numerical pitfall. A pitfall is something that trips us up, makes us make an error, or causes us to make an error. For example, if I take the following limit as x goes to 0 of the sine of pi divided by x, and if I make a conjecture from this numerically that the limit is 0, the numerical evidence might actually look like that's the case, but it's very wrong. And so sometimes numerical evidence just isn't going to be enough for us to calculate what a limit is. Turns out this limit really doesn't even exist, and I'm going to show you why it doesn't exist. So here's the graph of the sine of pi divided by x from negative 2 pi to 2 pi. And as you see, as we approach 0 from the left, this function begins to oscillate very heavily, up and down, up and down, up and down. And so let's change the window, and this time I'm going to let my x min be negative 0.1. I'm going to let my x max be 0.1. And I'm going to let my scale be 0.001. Let's see what we get. So yes, as we get closer and closer to 0, this function is just going crazy. It's going up and down. So I can't really say that it approaches 0 because it's oscillating so heavily. It just goes up and down, up and down, up and down, up and down. So in this case, the limit doesn't exist. Whereas if I had calculated it numerically, it may look like the limit there was actually equal to 0. And so that's a problem. So we call that a numerical pitfall. So be prepared to be given functions or limits of functions where you may encounter numerical pitfalls. And I want you to explain to me in words, in a sentence, what the pitfall is. Okay, that's going to become important.